Welcome to this new video on the right triangles.
Step by step, we'll follow the traces of the ancient builders, from ancient temples to great cathedrals. In this video, we're going to explore the properties of right triangles, including the famous 3-4-5 triangle we saw on the previous video. This triangle is a perfect example of what makes right triangles so special. It has a right angle that's 90 degrees, which means the other two angles must also add up to 90 degrees, since the three angles of any triangle always add up to 180 degrees. The longest side is called the hypotenuse, and it's always equal to the diameter of the triangle circumcircle. And of course, the most well-known property, the square of the hypotenuse is equal to the sum of the squares of the other two sides. For the 3-4-5 triangle, that means 3 squared plus 4 squared equals 5 squared. And indeed, 9 plus 16 equals 25. When you draw a circle around a straight line, let's say a line that's 5 units long, every single point on that circle allows you to create a right triangle. You don't even need to know the exact lengths of the two sides beforehand, but you can choose at least one of them, for instance, a length of 1 or 2. And just as a reminder, the gray line here represents the point of a compass. It's also worth noting that there is only one right isosceles triangle that can be built from a given straight line, and that's simply half of a square. It's also worth noting that there is only one right isosceles triangle that can be built from a given straight line, and that's simply half of a square. Let's get back to the 3-4-5 triangle. What made it so famous is that all three of its sides are whole numbers. But here's the real question: is it the only right triangle with this property? No, there are infinitely many. The simplest series comes from triangles where the smallest side is an odd number, starting with 3. The other two sides are found like this: take half the square of that smallest side, then subtract 0.5 for one side and add 0.5 for the other. In other words, the sum of the other two sides always equals the square of the smallest side. Let's check it with the famous 3-4-5 triangle. 3 squared is 9. Half of 9 is 4.5. Now, 4.5 minus 0.5 gives 4, and 4.5 plus 0.5 gives 5. There we have it, the triangle 3-4-5. The next odd number is 5. 5 squared is 25. Half of 25 is 12.5. Subtract 0.5, we get 12, add 0.5, we get 13. That's the 5-12-13 triangle. And it continues, the 7-24-25 triangle, the 9-40-41 triangle, and so on. Each time, Pythagoras' theorem is perfectly verified. For example, 13 squared minus 12 squared equals 5 squared. The same works for 7, 24, and 25, and it keeps going, all the way to triangles like 44, 924, 925, and beyond.
But that's not all. We also found the triangles 8, 15, 17, 20, 21, 29, 12, 35, 37, and even 16, 63, 65, among others. And if you were to draw a circle around them, do you remember how to do it?
All you need to do is find the center of the hypotenuse by drawing two arcs that give you the perpendicular bisector. That line marks the midpoint, and from there, you can use the hypotenuse itself as the diameter.
Any even number, when divided by 2 and then squared, can reveal a right-angled triangle made of whole numbers using the simple +1 - 1 trick. In this case, 16 divided by 2 gives 8, and 8 squared is 64. So 63 and 65 form a right-angled triangle with 16. Conclusion: any whole number greater than 3 can be used to construct a right triangle made entirely of whole numbers.
3, 4, 5.
4, 3, 5.
5, 12, 13.
6, 8, 10.
7, 24, 25.
8, 15, 17.
9, 40, 41.
10, 24, 26, etc.
This means there is an infinite number of right triangles that satisfy our initial hypothesis.
One final fascinating fact: all right triangles can tile the plane. We'll explore that more later. Thank you for watching this video.
See you soon for more discoveries on our channel. Sacred Geometry.